Hello friends. So today we are going to do two questions. So this is question number 1. Three blocks A, B, C of equal mass m are placed one over other on a frictionless surface, that is table. Coefficient of friction between any blocks A, B and C is mu. The maximum value of mass md so that the blocks A, B and C move without slipping over each other. So we are going to find out the maximum value of this block md. Let us call this a block D. So we are going to find out what will be the maximum value of MD for block D. Okay. So let us assume that this D block moves in the downward direction with the acceleration of A, and this A, B and C, they have a common acceleration that is also given as A. So we are going to have force tension here as well as here. You see, let blocks A, B and C move together with the acceleration which is given as A. Okay. So therefore, the acceleration of block D will be also A. Okay. So we can draw the free body diagram for block D. So this is our block D. So here will be MDG and a tension T, and in the downward direction it's moving with the acceleration A. And this is our block D. So we can say for block D, we can add the equation mdg minus T is equal to md multiplied by A. Let this be question number 1. So let's assume that B and C are one single block. Okay. Say let B and C are one single block placed over A. So we can draw this is our B plus C and this will be our A. So we have a tension T, and this tension T will try to force this B plus C along its same direction with a frictional force that is called Fr. So equal and opposite will be here also. So let us write it for blocks B plus C. So they have mass m, so this will be 2m, this will be Fr, and they are moving with the acceleration A. So we can write the equation that Fr will be equal to 2ma, and also we can write that our Fr is equal to mu 2m into g. So we can equate these two, we can say that our 2ma is equal to 2m mu g. So from here our acceleration A will be coming equal to mu g. Now we can consider the free body diagram for block A. So we can say for block A, A tension T, and we have Fr, it is moving with the acceleration A. So we can write the equation as T minus Fr will be equal to, mass is given as m, ma. So we can solve it further. Let me write it here. T minus Fr is equal to ma. Let us call this as equation number 2. Okay. So we substitute the value of Fr in this equation. Get T minus 2m mu g, and m acceleration we already know is mu g. We substitute it here. This will be mu g. Okay. So from here we can get the tension T. This will be equal to 3m mu g. Now using this value of tension and putting it in the question number 4. Okay. From equation 1 we get mdg minus 3m mu g is equal to md. We know value of A is mu g. G and G cancels out. We take md to one side, so this will be coming as md 1 minus mu, and this will be equal to 3 mu m. We can say our value of mass m, T, is equal to 3 mu m upon 1 minus mu. So this is our maximum value for block D, so that no slipping between A, B and C. So this completes our first question. The second question, this is our second question. So here the masses of blocks A, B and C shown in the figures are 4 kg, 2 and 2 respectively. Block A moves with acceleration of 2.5 meter per second square. We are going to have two questions here. Block C is moved from its position and placed on block A as per this figure. What is now the acceleration of block C? And the second, the position of blocks A and B are subsequently interchanged. Find the new acceleration of C. The coefficient of friction is same for all contact surfaces. So this is our original figure where B and C are connected with a string to A. So first of all we are going to use this part to solve it and find out the various things that will be further used for part A as well as part B. Okay. So you can say Let us call this as figure A. From figure A, now it is given that block A moves with acceleration of 2.5. You can see acceleration of block A is, let us call it AA, which is given as 2.5 meter per second square. And let me draw it here. So this is our block A. It is moving with the acceleration of 2.5, and we have tension T here. And for B and C, let us treat it as one system. So this is tension T, and obviously it is also going to move with the acceleration A in the downward direction. And the individual weight is 2 and 2, so this will be 4g. Okay. Say, considering B and C as one system, okay. Considering B and C and one system, so we can write the equation as 4g minus T will be equal to 4a. And we already know value of the acceleration. Okay. And we also have that, yeah, I forgot to mention, there is a FR acceleration also, the friction also. So for block A, we can write the equation as T minus FR will be equal to 2.5 with the acceleration, and mass is given as 4. And from here we can find out our FR is equal to mu mg. M is 2, M is 4, sorry, and this will multiply by G. So we can say our T is equal to this will be 2.5 into 4 plus FR. FR is our mu 4G. Let us call this equation 1 and this is equation 2. So we are going to solve the two equations. The first is 4g minus t is equal to 4a, and second equation is t is equal to, we will be getting this as 2, and this will be plus mu 4g. Put the value of t in this equation, we get our mu as, it will be coming as 0.5. So we know the coefficient of friction is now 0.5. Now we come to the part A. Okay. Part A, which is figure B, and figure B is given as so we have this block B and A, and what we did is C. So this will be tension T and this will be tension T. Now once again we say let both A and C are moving together with the acceleration A. Okay, let blocks A and C move together with acceleration a. So it means we have a plus c and the radial tension T, and there will be friction force Fr. So we can write this equation as, and they are moving with acceleration a. So we can say T minus Fr is equal to weight of A is 2 and A is 4, and this will be coming as 6a. And we can find out our Fr. Fr will be equal to mu 6g. So we put Fr, so we get this as T minus mu 6g is equal to 6a. That is this equation number 1. Now we come to for block B. So this is block B. Its weight is 2 kg, so this will be 2g moving the acceleration a and upward it is tension T. So we can write this equation as 2g minus T is equal to weight is 2a. Equation number 2. So we can solve equation 1 and 2. You can say from equation 1 and equation 2. Let me write it here. So we get T minus mu 6g is equal to 6a and 2g minus T is equal to 2a. We add them. So T cancels with T. So we get this 2g minus mu 6g is equal to 8a. From here we can find out value of a. A will be taking g as common, so this will be 2 and 6, this is 0.5 divided by 8. So we can write this as g, this will be 2 minus 3 divided by 8. So we can clearly see that our acceleration will be coming as negative. Therefore, the system will be at rest. Okay. Therefore, the system will be in rest because acceleration cannot be negative. If system is at rest, so we can say that acceleration of block C will be 0. So this completes our first part. Now in the B part, it says that on B part, it says that the position of A and B is interchanged. Okay. For B part, position of blocks A and B are interchanged. So we can draw the diagram like this. Now this will be our block B, block C, and this will be block A. Tension T and T. So let us suppose they move the same acceleration A. So we can write for block A. So this is block A. its weight is 4 kg, so this will be 4g upward tension T and moving with acceleration A. So we can write the equation as 4g minus T is equal to 4A, equation number 1. Okay. And we say let B and C move together with the acceleration A. Let blocks B and C move together with acceleration A. So for B and C, this is B plus C, tension T, we have a FR, and they are moving with acceleration A. So now we can write the equation that T minus FR will be equal to, the B is 2 and C is 2, so this will be 2A. We can find out FR will be equal to mu 4G. We substitute the value of FR, we get this equation as T minus mu 4G is equal to equation number 2. So now we are going to solve equation 1 and 2. You can say using equation 1 and 2 we get, so we have our 4G minus T is equal to 4A, and we have T minus 4 mu G is equal to 2A. We simply add them, this cancels out, so we get this as 4G minus 4 mu G is equal to 6A, or we can say our acceleration is equal to 4 minus 4 mu is 0.5, G is 10 divided by 6. So we get the acceleration as 2.5 meter per second square. Now this is the combined acceleration of B and C. Okay. So this is combined acceleration of B and C, because they were assumed that they are moving together. So we are going to find out whether there will be any slipping between B and C. If there is slipping between B and C, they both will be moving with different acceleration, and if there is no slipping, then this value will be the acceleration of C. Okay. So we can say check for slipping between B and C. So we have our, this is our block C and this is our block B. We have a tension T which is forcing the block B to move to our right. So as there is friction between B and C, so it will be FR, and this will be also FR. Okay. So you can say for block C, for block C, FR, we know that the acceleration which it can have is 2.5. So FR will be equal to 2 into 2.5, which is equal to 5 Newton. And the maximum value of the friction for block C, maximum value of friction can write as Fr max will be equal to mu mg, and mu is our 0.5, mass is our 2 kg, and g is 10. So from here we can say that our Fr max is equal to 10 Newton. Fr max is 10 Newton. So if you make a comparison between Fr and Fr max, you can clearly say that our Fr is less than Fr max. So under this condition, no slipping between B and C. So if there are no slipping, they both move together. They both move together with the acceleration A, which is equal to 2.5 meter per second square. This completes the both parts for this. Thank you.